All right, so Cartesian plane x, y, and what we have is we have two coordinates. Now remember, we always write the x coordinate first, okay? When we write a set of coordinates, it's always x, y, and you can just think of the alphabet. X comes before y. X, y, z, right? So we can see the first point is x is 2, so we've gone across 2 spaces, and y is 5, so we've gone up 5 spaces. Here we have x is negative 3, so we've gone to the left 3 spaces, and y is positive 7, so we've gone up 7. That's how we plot points on the Cartesian plane, right? What we're doing here is we're saying, how far apart are they? If you're going to walk from one to the other, how many units is it? That's the distance between them. And then the other one is, what's the midpoint? What's the coordinate that's exactly halfway between them? So let's do the distance first. We're going to use what's called the distance formula. Okay? Looks like a reasonably complex formula because there's a bit involved, but it's not too bad. So what I'm going to do, I'm going to write the coordinates here. We've got -3, 7 and 2, 5. Now, to either of the coordinates, we're going to assign x1 and y1. That's the first coordinate, okay? x1, y1. Over here, this is going to be our x2 and our y2. We're going to assign a subscript to each coordinate, okay? So here, notice how they both have 1. That's because they're the first coordinate. Over here, they both have 2 because they are the second coordinate. Now, I'm going to write the distance formula below it. We've got x2 take x1. Okay, and now all we need to do is substitute these numbers into their corresponding position in the formula. Okay, so here's the formula, and straight away I'm going to go, where's x2? Because that's the first thing. x2 is the number 2. So I'm going to put the 2 there. So we have 2 take away, and then I've got x1. I'm taking away x1. What is the value of x1? It is -3, okay? -3 corresponds. We do need to include the negative sign, okay? So I'm going to put it in brackets. We have 2 take away -3. All right, x2 take x1 squared. All right, then we're going to have plus y2 corresponds with 5. Take away y1 is 7 squared. And the square root extends over the whole calculation. Okay, let's process it. So in terms of bed mass, we have to do the brackets first. We have 2 take away -3. When we have those two negatives next to each other, it becomes a positive. So we're going to have 2 plus 3. Here we're going to have 5. 5 is inside the brackets. And then we've got 5 take away 7. Okay? 5 take away 7 -2. So if you need some help doing those kinds of calculations, not real sure, please let me know. But we have the plus, that stays there. 5 take 7 is -2, and that one is squared. And all we're going to do is keep processing this until we arrive at a solution. So 5 squared is 25. And -2 squared is -2 times -2, that's +4. Square root of 29. That's how far apart they are. That's not particularly useful if you're asking for a distance though, is it? So does anyone want to have a guess what the square root of 29 is? A little bit bigger than 5? Yep. How'd you arrive at that, Charles? Perfect. Great reasoning. Okay, so we know the square root of 25 is 5, and the square root of 36 is 6. So the square root of 29 has to lie somewhere in between there, doesn't it? Okay, so we can inform our answer with reason, but we can also check on our calculator what's the exact distance. So I don't know, do I bring my calculator? Yeah. So, that's that one. got 5.38. 5.385. Okay, so we'll do a little bit of rounding here as well. I'm always going to write 4 figures and then always round the 4th one. And I'm going to get you guys in the habit of doing it too. So always write 4 numbers and then the last one rounds. 5 rounds up, so it's closest to 5.39. Okay, that's 3 significant figures. Okay, so that's the distance between these 2 points. That's part A. Part B, find the midpoint of these coordinates. So that just means, where's the point in the middle? And you could just sort of use a bit of reason about this, all right? We're 3 that way and 2 that way, so that whole thing's 5.5. 5 is 2.5. All right, so we could use a bit of reason, or we can use what we call the midpoint formula, which is this one. So let's go ahead and do the midpoint. So that was part A. Here we're going to do part B. And we've already assigned these values x1, y1, x2, y2. So the midpoint formula says x1 plus x2 divided by 2. So we're going to have minus 3 plus 2 divided by 2, comma. Okay, it's a coordinate, isn't it? So we've got the x coordinate, and then we need the corresponding y coordinate. For the y coordinate, y1 plus y2 divided by 2. All right, and then we're just going to evaluate this. So minus 3 plus 2, that's going to be minus 1. And 7 plus 5 is going to be 12. Now, minus 1 on 2, that's just minus half. You can, if you want, leave it as a fraction. You can, if you want, express it as a decimal, minus 0.5. And 12 divided by 2 is positive 6. All right, so the coordinates of this point in the middle are minus 0.5 and 6. Very good, so that's our first one. We've got another example, which we'll do a bit quicker. All right, so I might leave that one up there, I think. And we'll just look at question 2. So our coordinates for question 2 are minus 1 and 3, and minus 2 and minus 4. Okay, there are our coordinates. So step 1, we're going to go through and label x1, y1, x2, y2. Now it doesn't matter which one corresponds with 2 and which one corresponds with 1. If you do it the other way, it's still going to work out. That's the beauty of this algorithm. Alright, so then we'll go straight to the distance formula. The square root of x2 take x1 squared. So I'm just going to go straight into it. Minus 2 take away minus 1 squared. Alright, x2 take away x1 squared. That's the first part. Plus, and then we have y2 take away y1. I need the bracket there. Squared. The square root extends over the whole calculation. Let's process it. Minus 2 take minus 1. So this becomes minus 2 plus 1. Minus 2 plus 1 is going to be minus 1. So we have minus 1 squared. And over here, minus 4 take away 3. You're at minus 4 and you're moving 3 units to the left, will be minus 7. Alright, keep processing. Minus 1 squared is positive 1. Minus 7 squared is 7 times minus 7 times minus 7, that's positive 49. So we'll have square root 50. Now, I am happy for you to leave your answers as surds. Okay, that's what we call a surd. It's got a root over the top. That's expressed exactly because it includes every possible decimal point, right? If you want, you can put it in your calculator to get those figures. Okay, let's ask that question again. What do we expect this number to be? just over 7. 7 squared is 49. 8 squared is 64. So this is square root of 50, so that's just over the square root of 49, isn't it? So just over 7. Really good. Okay, so that's the distance, and then we'll do the midpoint. So I'm running out of a bit of room here. Okay, does anyone object if I rub this one off? No, I like to make sure everyone can see it, so I don't want to write it too small. It's pretty average. Okay, so for the midpoint, we're going to have x1 plus x2 divided by 2. So minus 1 plus minus 2 divided by 2. That's the x value. Adding the two x's together and dividing by 2. And then for y, 3 plus minus 4 divided by 2. That's a bracket. And it's a coordinate, so we need brackets around the whole thing. And then we're just going to process it. Minus 1 plus minus 2. That's the same as minus 1 take 2. That's going to be minus 3 on top of 2. And we have 3 plus minus 4. That's the same as 3 take 4. It's going to be minus 1 on top of 2. Now we can actually leave our answer like this, right? Because I said we can express it in fractions. 3 on 2. 3 over 2, that's 1.5. So we can have minus 1.5 and here minus 0.5. So here, full marks there, that's fine. I like fractions, leave it like that. If you want, evaluate it to decimal, still get full marks there as well. Okay. Same, backtracking to our distance, full marks there. You feel free to evaluate it to 3 significant figures. Make sure you round it properly, of course, like we've demonstrated over here. Excellent. So there is one more example about where we derive the distance formula from. We might go over that a bit later. Okay, so that's more sort of a bit for fun, that question. So that's 11A and 11B. All right, so we're going to start pretty slow. Hopefully we're all on the same page with that. And I've got a number of problems I want you guys to have a go at yourself. So in the linear equations booklet, we're just doing question 1, recommended extension, question 5.